To begin with, let me just give a quick introduction about who I am and what do I do. So I've been working at Microsoft for around close to 4 years now. I'm a SDE and I'm working with the Azure hardware and system infrastructure team. And I have been freelancing as a coach, as a career coach for the past few months. And I've been a part of Carrus for around 3 months now. Um, so at Carrus, uh, I help my students or I help my candidates in creating a personalized study plan for themselves or creating on-demand curated sessions for themselves if they have problems that they want to want my assistance on, and if they want to sort of sharpen their problem solving skills, and if they have some doubts that they want to get solved in a session, I provide that. uh, Apart from that, we have code reviews and resume reviews where I tell you why I feel that something in your resume is not how it should be and why we need to change that in what way. I help you make your resume ATS friendly, and so that if a recruiter is scanning your resume, they can detect the right keywords and basically know what the person that you exactly are. So anything that you're trying to market yourself for, that is something that should reflect for the other person as well. And lastly, I also take mock interviews, depending on whatever your topics are and whatever your job, the job that you're applying for is. I curate mock interviews and I conduct mock interview sessions as well. You can avail these sessions at this given link. I'll try to see if I can pass out this PPT in any way. Otherwise, you can just head over to Caris and search for my name, and I think you'll find it. I'm a little optimistic that I'll be the only person with this name. So let's get started. Any questions so far? I see someone has. Yep. Okay. So just to give you an idea of what we are here for and what is the roadmap for the session. Uh, in this session, we'll cover the importance of creating a study plan. I'll share my best practices on how I create my study plan whenever I have to go for an interview. What are the key topics that you have to include? It's not an exhaustive list. It's not it doesn't complete everything that you need to have, but at least it gives you a good starting point, because time and again I've felt that when someone comes to me and when someone approaches me, the first question that they ask is they don't know where to start. So the key topics to include helps you in having a start, okay, giving you a starting point that you can come for. Next is we talk about making notes and writing code skeletons. Now, if you're a little, uh, I don't know, skeptical about what, if you're unclear about what code skeletons mean, this is something that will be clarified in the future segments, and I'll even show you a few examples on how I create them and what is the purpose of it. Why do you need that? I talk about my personal 9 step interview approach. This has helped me a lot. This is something that I have, it's something that I've put close to my heart. And, whenever I'm appearing for an interview, I make sure that these 9 steps are something that I keep as a structure, because it also helps me provide some structure to my own interview. If I'm coming in front of an interview, I want to make sure that these 9 steps are something that I personally follow. So I'll tell you the significance of each of these steps and how and why do you actually and how do you actually go ahead and implement these. And lastly, I know that the session is scheduled for an hour, but if time permits, I'll also host a small Q&A round. In the meantime, please feel free to ask any questions in the chat. I think unmuting is disabled for you folks. So in case of any questions, just ping in the chat, and Gabriela or me will take a short time to answer that. Okay, so let's get started with that. Uh, I also want to set the scope very clear with the topics that we will not cover, because that's something that I know I have talked about a little in terms of the things that I do at Caris, but given the time constraints, we want to ensure. I mean, I want to ensure that we are very clear with the scope. I'll not be working on resume building, and I'll not share resume building tips based on any job description. I'll not be helping in a very personalized study plan on this session. We do not have practice problems to go through, and we're not covering low level or high level design concepts. These things can be availed at my Carrus profile, but for the sake of this session and to respect the time boundaries, we'll not be going through these. So first and foremost, we will be jumping to creating a study plan, but I'm assuming no questions so far. I'll just give a few seconds. If you have any questions, please put them in the chat. And if it's clear so far, let me know. And if there's something that you want to be included in the session apart from what I've already said, please let me know and see. I'll see if I can include that in the end. All right. So I'm assuming everything's fine, and I'll move on. So creating a study plan. I think I'll circle back to the point where I said that people often tell me that they do not know where the starting point is, right, and where how they have to have their own roadmap. In that case, creating a study plan for your interview preparation that helps a lot. Okay, uh, how I do it is I take a list of every topic that I feel that I need to know. It's something that can be clarified in terms of the job description and the level of the role that you're applying for. If it's a very senior role, then you'll probably need concepts like you'll need to implement concepts or data such as like tries and segment trees, graphs, and you need to know comprehensively about these things. And you might also need to know a little bit about the complex algorithms that are there in place. But if it's let's say an SD1 role at a very or it's an entry level software engineer role, in those scenarios you just need to get your basics clear. I mean, you have to understand what is the expectation from this particular role or the person who actually lands this particular role, and you have to prepare yourselves. Uh, Given, I mean, likewise. So first things first, create a list of topics that you feel that you want to go for, and the topics that you need to cover. Ensure that you're also covering the topics that you already know that you've already covered. We'll tell how we can separate those in the coming segment. Color code these things. You can use any sort of color coding you like. I personally use three colors: green, yellow, and red. You can probably use more. For me, try to keep it as simple as you can. You don't want 20 colors and you spend more time in identifying what color means what or what is the significance of each color instead of actually getting some work done. So how I do it is I divide my topics into three segments. The first is the green colored chamber, which means that the topics that are color coded green are done, where I have actually gone through these problems. I have confident that if a problem from that category comes in, I'll be able to solve it. And I don't have to look back at that until unless I'm done and every topic is in the green basket, in which case I can just go ahead and revise. So that is green. Red is something that is very critical. For example, if I'm even if I'm appearing for an entry level job, hash set and hash map is something of a critical topic for me. But I feel that if I do not have right amount of knowledge for hash set and hash map, then I would put that in red and I would make sure that I am covering that up. Before anything goes before I'm done with my preparations. And yellow is either for the topics that are not very critical or topics that I have done, but to some extent, but I'm not too confident about. So let's say it's an entry level job, and while knowing graphs could be a good advantage point, it's not very necessary. So if time permits at the end, maybe I can just brush off over graph and or let's say I have done trees to some extent, but I'm not too confident about it. However, spending any more time on trees at this point would sort of, I don't know, make it difficult for me to catch up to other points. So I would probably yellow code it, right? Uh, Ashmika, I see a question from you. I'll jump to that at the end. Find learning resources you need for the red topic. And I think that is something that the question that has been raised about where should we prepare DSA comes in. One of the most important part of the of learning code, how to code, and learn becoming an efficient coder is practice. There is no easier way to say it, right? Personal preferences, I use lead code a lot because it's a very there are very variety of questions. It's a very large community. You see a lot of you see a lot of different solutions. You see people explaining the minute concepts to you, and it also gives you a sense of where you stand along with others in terms of your time and space complexity. So the first resource, let me just type it down, would be leadcode.com for practice. For studying, I think there are this. It's a very controversial point, right? Because to be fair, I don't think there's any uh, hard and fast studying book that you need for or no, hard and fast study source that you need for DSA. Just pick up your favorite data structure and algorithm book and get started. That's the best. You can get CLRS, get started with that. Okay, uh, and maybe along the lines you will find what you're looking for. If you have your basics clear, then I would say start implementing right away. Probably YouTube is your best source. It depends. It really depends from person to person. Some people are not comfortable with videos. Some people are not comfortable with reading that those fat books. So I'll just leave it to you. However, if you're going for books, you can go for CLRS, and if you're going for, let's say, videos, there are plenty of YouTube channels out there. So yes, find the learning resource you need for the red topics. Uh, if and given all these topics, have the URLs. Let's say if you're finding the resource online, right? And if you're sort of compiling all the resources for each of the topics, then in the study plan, have these URLs written side by side so that when you're jumping on that topic, you don't spend time in finding the right resources. You have the resources shortlisted and you can directly jump into studying and preparing on that. Okay. You can maybe also have some specific problems. For example, if you are going for recursion, right, then you can have some problems specified to recursion. Maybe you can have finding the factorial of a number using a recursive method, or finding the Fibonacci sequence using a recursive method. So just write these problems down and keep them for your own reference at a later point, that you don't feel confident in solving these problems right now, but at your measure of confidence for a particular topic comes from whether you can solve that problem or not. So that could be your metric for your own performance measure. And lastly, this is not at all necessary. It's something just that I do, and it gives me a sense of achievement every now and then. Every problem that I solve, I create a repository for my own purpose. Okay. There is, I mean, you don't even have to revisit this repository later on. It's just that if at any point you want to uh, go ahead and if you want to revise the uh, solution that you have, let's say you wrote a solution for something and you want to go ahead and you want to make it more efficient, then you can maybe look back. It's not very uh, practical, but there's no harm in doing it, and there's no harm in having your own repository. I think, Gabriela has posted a link of my GitHub repository. You can check that out. Don't I would highly recommend against it to use it before you actually solve a problem out. But it's something that you can keep as a handy reference. Okay, it can give you an idea of the kind of problems that you want to solve if you're trying to go with DSA. I'm also sending the link to my LinkedIn profile, which I should have done at an earlier point in this conversation. But please feel free to connect with me on LinkedIn. And yeah, I mean, I would love to have more of a connection. If you have any doubts, you can also reach out to me anytime over there. So, any questions on the study plan creation part? Anything that you'd want me to throw more light upon? Cool. Either I'm a great teacher or you are having a little or you are a little intimidated for even asking the questions, but I'll give myself the benefit of the doubt and I'll go for the former and I'll proceed. So as I said, right, I'll help you with the key topics for preparation. So I think first is I've tried to divide the key topics into three segments. One is data structures, another is algorithms, and lastly are the concepts that not many people talk about. You won't find this in, just give me 1 second. Yep. You won't find these in lots of articles. You not, uh, anytime you approach someone and ask them for data structure and algorithm coding preparation, they just say that study your DSA wisely. I feel that we should take it one step ahead and be prepared for the follow-up questions that come after you're done with making your program or writing your code. And I mean, some of these concepts also influence the kind of code that you write. Okay, so let me start with the data structures. Hash maps and hash set. I can't stress on how important these are. Um, if like there's the probability of a question being solved with hash set and hash map and decreasing the time complexity by great extent is a lot. So please use hash set and hash maps wherever you can. Stacks and queues. That's another point over here, where there are a lot of these scenarios where uh, the solution cannot go forward without the use of these data structures, and it just makes a job a lot easier. Stacks in particular is much more important in my opinion, because there are, even if you're going for recursive versus iterative implementation, the memory resides on stacks, and if you're looking to build an iterative solution for a recursive problem, stacks come in very handy. Moreover, stacks and queues come in very handy when you are going for problems like TFS and DFS, which is depth first traversal and breadth first traversal. If you don't know it, no need to worry. Just know that these are two jargons that do exist, and they help us in almost all the tree and graph problems. So, yep, that's something that you need to be very about. Trees again is a fairly, I feel, I mean, while it's not that difficult, for an entry level, you might not get very complex questions from trees, and you should have some grasp and some knowledge about it. Strings and arrays is the most fundamental data structure that comes into place for the coding interviews. And then again, lastly is linked list. So for most entry-level jobs, string, arrays, linked lists, stacks, queues, and hash set hash maps are generally enough. I've added trees over here just for an added advantage. And yeah, and this is not a comprehensive list. If you want to go ahead, you can also go ahead and ramp up on graph, tries. I'll leave it to your research, but this is something that you can begin with. Then comes the algorithm part, where I mean, I've written down these algorithms. We can have sorting, binary search, sliding window, greedy, divide and conquer, dynamic programming, BFS versus CFS. Uh, Sorting, binary search, and sliding window are some problems that are used on most of the string and array problems. And I think greedy, divide and conquer, and dynamic programming are a little, not divide and conquer, but I think greedy and dynamic program are just a little advanced as compared to the prior three in terms of uh, thinking process and having and sort of imbibing them in your intuition, that when you see a problem, this is something that comes to your mind. BFS versus DFS is a concept that requires lots of practice. A shorthand of rule is that you use BFS when you're trying to, let's say, find the shortest path possible, and you use DFS when, let's say, you have to find that a particular thing exists or not, right? So those things, and I mean, BFS, DFS naturally comes down to whether the height of the tree is longer than the width of the tree. That is it. And concepts that you must go over is, one is measuring the space and time complexity of a program. It's a very good idea that at the end of the program you give the space and time complexity to your interviewer, because it just gives the idea that how self-aware you are about your own program, about your own knowledge and about your own skills. So yep, that's there. Memory stack versus heap. You have to understand where is the memory located and where is the memory called from. It depends on the implementation, but stack heap memory is generally more costly, and that's we try to be very mindful about the memory that we're using on the heap. So whenever you're creating a program, the interviewer might go ahead with follow-up questions that require and go around which kind of memory is being used and what kind of and why how you can how would a destructor, if it's an object oriented programming, right, how would a constructor or a destructor behave on these memory components. So it's a very handy thing to understand these concepts by heart. Don't memorize this, just know this. And lastly, a concept that is not uh, fairly important, uh, but it is. I mean, I don't see a lot of people specifying importance to this, but I feel that knowing the recursive versus iterative implementation is very important because recursive solutions always come with a weight of uh, recursive solution always come with a weight of added stack space on the memory. Okay, and you need to identify if you can have an iterative solution without having that space consumed. So that's one, and also in general, when you're going for BFS and DFS algorithms, iterate being familiar with iterative coding really helps you in implementations of these two traversals. Because if you're going with a DFS traversal iteratively, or even if you're going for pre-order, post-order, and in-order traversals of trees, it's something that you need to be aware that this is how I can do it iteratively, and this is how I can do it recursively. Not too important, but I would definitely, it would really help you in clearing your fundamentals. So before I go, let me just take the questions that are there. Please feel free to ping the questions at any point of time. Okay. Is lead code a good place to practice dynamic programming? I would say yes. I would say yes because lead code has a range of topics and a range of series problems that help you in sort of getting an idea of how uh, it helps you brush up on the most common and fundamental problems or theories about dynamic programming. There is one problem in particular, which is a 5 problem series for best time to buy and sell stocks. What they do is, with each problem, they increase the difficulty of the uh, problem standards. Okay, so let's say the first problem is an easy one, and probably requires just a normal traversal and just adding up of differences. The second solution requires a greedy approach. The third operation allows includes dynamic programming. Fourth approach, and so on. They just keep increasing the complexity of each of these. So I would say lead code is a great place to start and practice dynamic programming. There are a few posts on LinkedIn as well as lead code where you will get uh, summarized questions from each topics or each type of dynamic programming that there is, and it will help you in mastering that particular concept or trying out everything that you can in that particular concept. I think LeetCode also has a study plan for dynamic programming questions, so make advantage of that. Alternatively, you can also go to my repository, and there are a lot of there'll be a few commits that mention dynamic programming problems. You can see the problems that are mentioned in that particular commit, and you can try those out. That's the easier way out, I believe. So, yep, I hope that answers your question, Khushbu. Next is Luca about complexity. How important is to use slash know the master theorem? Um, I it's not there is no I think when it comes to complexity, people don't dig in a lot of why and how you arrived at it. Uh, for me, I don't use the master theorem a lot. I have it's for me it's intuitive. Okay, I look at a problem, I look at a solution, and I can figure it out in my head. Okay, so if that works for you, great. If that doesn't, master theorem sort of allows you to break down the time complexity and the space complexity in mathematical forms. Okay, and that makes it sort of easier, and that also makes you a little careful about calculating time complexity. I mean, maybe if I'm going intuitively and if I'm just taking one glance at the code and trying to figure out my time and space complexity, I could go wrong. But then master theorem is a little foolproof way of breaking down the entire problem into mathematical terms and then going ahead and finding what the time and space complexity is. So I mean, it really depends on the preference. However, if you're not sure, go ahead and study. That would it's not going to do you any harm, and maybe it will also help in building your intuitive approach towards finding time and space complexity. I hope that answers your question, Luca. All right. Since I see no more questions, I'll move on to the next slide. Art of making notes. Okay. Um, for an example, before I go ahead, I'll take this particular email. Okay. This is the sample email. You could give it a quick read, or maybe I could read it out for you. Hello, Harsh. Great talking to you. How have you been? I have been good. How are the kids? Oh, I forgot you're not married. Haha, just kidding. I want to discuss something with you, man. There was a discussion about a product. It was so tiring. I was tired. Literally so tired. Tired, 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 man. Really tired. So tired. Did I say I was tired? Anyway, they want you to give a demo tomorrow at noon. I hope you don't get as tired as I was. So tired. Regards, Harsh. If I asked you to make notes out of it, right? You have to be. I mean, maybe you could go ahead and use highlighter. That's what I do. Because if I'm going through a particular topic and if I need it for revision later, I won't go ahead and read the entire thing again. I try to minimize the amount of time I have to spend in revising. So what I would do is I would highlight, but some people don't understand the concept of highlighting and they end up highlighting the complete thing. And it's not really important. I mean, this complete email is not important, right? The only important part in this email is this. So what I do is, or what you should do is be very mindful about how you are creating your notes. Understand the importance of the kind of things that you have highlighted, and make sure that you're doing this for the future you. Okay, the future you shouldn't look back at you and curse at you for not being for making them do the same thing again and again. So be a little mindful and try to minimize and try to identify what's exactly important and what's not. Okay. Next is I think the most important part of this session that I believe. It's something that I do personally. Again, it's a preference. It really helps me, and I've seen this to be a great, great addition to my knowledge. And it also helps me in identifying patterns to problems. Uh, what are code skeletons? It's a template of code snippet that could solve multiple scenarios and that could solve multiple problems. So maybe you could, remove and replace a few parameters here and there. Maybe you could make a few changes, but the same template or the same skeleton applies to a range of problems in that category. I'll give you examples and not leave you hanging like this. We have two examples for this, and I'll come to that later. Why do you need to write it? To sharpen your thinking process and identify patterns in problems. When you are writing a code skeleton, you need to be mindful about how how like you become more aware about the patterns that are coming up in problems. And it also helps you in having a better intuition when you see a problem, because you could easily see that it's fitting a given pattern of problems, right? This comes in really handy in interviews. This is not something that you have to learn. Okay, it's just something that you have to identify. It's just something that you have to acknowledge that I understand that this particular topic, it has templates. Like all the problems around it probably go around the same template, and it could help me in solving a lot of my saving a lot of my time and solving a lot of the problems at least. Two examples that we are talking about here will be backtracking and sliding variable size window problem. I'll show you the skeleton that I have written. Okay. Uh, Please note that you should go ahead and take this time to write your own code skeletons. Never ever copy someone else's code skeleton, because you are doing this for you. You are doing this for to identify what is your learning. Okay. So if I'm talking about the code skeletons, this is my code skeleton for backtracking. Okay. I understand that not many people might be aware with backtracking. So I'll just give a short run of what's happening here. For backtracking function, I constantly check if my base condition is being met. If it is, then it's a valid solution and I add it to my list of solutions. If the solution so far is invalid, I stop the execution. And if the solution so far is okay, for the current instance or for the current element or for the current index, I go ahead and I change the value to every value possible. And then I call the backtracking function again, and then I change the value back to what it was. Okay. So this in itself, okay, this helps you in creating a better function, and it helps you in creating a uh, better backtracking problems. You could take the skeleton and you can go to any backtracking problem. Let's say you go to n queen problem, you go to Sudoku solver problem, and these things will be valid because this is essentially what it is. This is essentially how you approach backtracking. Second is sliding variable size window. Same thing, right? I noticed that there was a frequency in the kind of problems that I was trying to solve, and I created a frequency map. And I created this template where you create a frequency map for the string, and you update the frequency map, which is the frequency of each of the characters, and then you just apply a sliding window problem, and you see how that works out. It's the same thing. It will work for most of the sliding window problems, and it will give you the correct answer that you desire. So that's another point. Yeah. So questions so far about how you can proceed with writing this, and what are the best ways to handle code skeletons, and when can they come to use? Anything around this? Folks, please feel free to ask any questions. Okay, it's important for us to have make sure that if I'm going and if I'm teaching something, or if I'm uh, talking about a concept, my main goal is that you get it. Even if you have not understood it, I'll go over it once again. But I need to ensure, and I want to ensure that at the end of the day, you are well versed with what is going on, and you don't feel left behind. You don't feel confused. All right, then let's move forward. The 9 step approach. Okay. Uh, this is when you finally get into an interview. You have landed an interview, you are in the room with, or you have an on-site, and you are being given a coding problem. Now, what are the 9 steps that you would follow to sort of, go through it and uh, analyze the problems, and how would you actually come to the solution? So these are the 9 steps that I follow. First thing is, let's say I give you a question. Okay. I tell you that I need you to find out the maximum possible sum in a given array, or the maximum sub array with, like a sub array with a maximum sum. Okay, you can ask me questions that are not clear for you. You can ask me whether the values are, if it contains negative values. You can ask me about the data type of values that are there, the range of values that are there, and any question that you think will be important for you to uh, answer, or come up to a solution. Go ahead, ask. Remember, no question is stupid, and but still, if you feel that the question that you're asking is very silly, and it helps and but it stops you from going anywhere forward, you have to ask it, because it's better to go ahead and look, I don't know, unclear once, than to go ahead at a later stage and feel unclear later, because the interviewer will feel that you don't know the entire thing, you don't have your fundamentals clear, whereas the only thing that was not clear was your approach and your understanding of what the question actually demanded. So ask as many questions as you can. Think out loud. If you're approaching a problem, if you're starting to solve a problem, if you're just thinking about that problem, speak everything out loud. Because if, let's say, I am interviewing you, as an interviewer, I need to understand what's going through your head. I need to understand, I don't just need a solution from you. I also need to understand how you arrived at the solution. What were the thoughts that you used to discard the other solutions? So think out loud. Okay, it's very important. Just talk. Just talk. Don't think in your head and leave me confused. If you're thinking in your head and I do not know what you're thinking, I'll just assume that you do not know the answer and you're not going anywhere forward. Or maybe you're just trying to recollect a memorized solution. Okay, I need to understand how you came. I need to make sure that your fundamentals are clear. Um, what can you do in this thinking to a stage that helps in clarifying the problem a lot more for you? Draw examples and think of expected output. What if this was my input, right? I asked you to find the maximum length of the sub array with the maximum possible sub-array with the maximum sum or the maximum sum of a given sub-array. You can find for send in a few arrays and you could think what would be the answer for that. You could try to add negative numbers here and there. You could try to add zeros here and there, and you would see how that changes your uh, answer, changes your output. In these cases, you can also use this pointer to confirm with your interviewer about what they feel if a particular exam output that you have given, if that's correct or not. Maybe I don't know that the value for let's say if a value goes on greater than int max, what should it be considered as if I'm taking integer data output, right? Just things like this. uh, so just think of every base case scenario, extreme case scenario. If you understand what the output is great. If you don't, if you need clarity, come back to the first step. Ask. It's that simple. Then identify the family of patterns. This is something that is also that where code skeletons help you. You don't have to memorize the solutions, but there is no harm in identifying the pattern that there are many questions that follow one pattern, and there's no harm in knowing that. So if you're seeing a question, get your intuition to use, get your intuition to good use and identify that which family of pattern does this particular question belong to. For example, if I asked you to check if a particular string belongs in another string, or if it's if one string is a substring of another string, then you could probably think that one way to solve this would be sliding window, where I could uh, instead of going ahead and calling a substring function at every character, I could just use sliding window and a hash map and identify what needs to be done. So these things come in handy, and these things help you in identifying, um, a better, at least get you into moving into the right direction. Next is you can break down this problem into primitive steps. You can simplify the problem that, okay, what we have to do is we just need to check if the characters that are present in one substring are present in the other as well, and in the same order. So you could probably find that if the characters in the current string is present in another string or not. And then once you simplifies that, maybe you could scale it up to meet the requirement that you have at hand, where your constraint is that these letters should be continuous. Okay. So that really helps. That really helps. Um, Identify your base cases. Um, identify where um, identify where your base cases are and when should your program stop, and what are the inputs that will have a predetermined output. For example, if I asked you to generate a Fibonacci sequence till nth character, okay, you know it that if the value of n is 0 or 1, sorry, 1 or 2, then the value that I need is 1. But if whenever I'm writing a generic program, I'm just assuming that the first and the second, the number that n that is given out, it's greater than 2. So you need to add base cases for the values that are less than 2. And that's where identify base cases comes into picture. Identify data structure to use. Uh, let's just take the sliding window example where I said you have to check whether one substring exists in another. You could go ahead and you can call a substring function at every point, okay, but that will have a it'll have a worse complexity than what you would do normally. It would probably call for an O(n) square complexity, O(n star m complexity, and a sliding window could achieve that using an O(n). So what is but you'd also need let's say a vector array or a hash set or hash map to store the frequency of all of the characters. So you have to identify which data structure to use. You have to walk the interview through your thought process about why you're using that data structure, how if that is necessary, or how would that help in reducing the time that our program takes for consumption, let's say a brute force or in a less optimal solution, and then go ahead and put that to use. At any point of time, try to look for the best data structure that reduces the time complexity as much as it can. Um, Um, Next is implement first and improvise second. In an interview, it's natural for you to panic. Okay, it's natural for you to look at it and be like, okay, you know what? Uh, the solution that I have in mind is brute force, but brute force solution is never that something that's going to be accepted. Uh, let's discard this. Look for a better solution, better solution, better solution. The problem with this is you don't even give a brute force solution in this case. Okay, and you can't tell when your mind wanders off in a direction that cannot do you any good. So in that scenario, implement first. Okay. If you can't think of any other solution, implement the brute force. Then look for improvement from there. Once you have the solution down on paper, then you can try to see, okay, you know what, this operation over here has been repeated multiple times. How about I stop this and I improvise over here and make it more efficient? Or if you see that a particular operation is very costly and it can be reduced by the use of a separate data structure, then over there, that is when the improvisation comes in. It's completely fine if you don't come to your optimal solution at the very first glance. It's better if you do, yes, but it's okay if you don't either. As long as you're reaching to the optimal solution by the end of the program, that's great. By the end of your interview, that's great. And last thing, one thing that I've seen with the interviews that I've taken is people give the solution, and I have to be the judge of that whether it's the right solution or not. There are scenarios where I can't tell because your implementation is something that I've not ever seen before. Because one problem can be solved in multiple times or multiple ways. I can see the time complexity and the space complexity of a problem, but I don't know about the accuracy of a program. So in that scenario, you have to try it because you don't know that either. Okay, how are you so confident about pitching a solution to me when you don't know whether the solution will work based on the case or not? And if it would, then prove it to me. Take a sample input, run it through your program, and see how how you what if the expected output matches the output that your program is generating. You can also uh, for the test cases, the best way and the most impressive way is when an interview whenever a candidate goes ahead and uses the edge cases. If they use negative values, if they use values that exceed the limit of the data type that they have used, and how is the program handling that? And if that was a condition that I have specified that this will be the limit of the value that I have given, all those sort of things. And also provide the time and space complexity of a program. That's a very decent thing to do. It helps me understand how well you know your program, how well you know your coding, and that is it. I mean, these are essentially the 9 steps. So I'll go to the questions. Khushbu has first. Can you give some more examples of family of patterns apart from backtracking and sliding window? Oh yes. Uh, uh, I have one for matrix chain multiplication, where there are a lot of problems that get solved with like the concept of matrix chain multiplication. Um, that's one thing. Then let's say if someone asks you the number of palindromes, that's something that fits in the same family of problems. And I have few for uh, dynamic programming as well. I have a dynamic programming code skeleton written down. It helps me for problems that come under the family of knapsack problems, or I mean, I hope people are aware of the infamous 0 1 knapsack problem over here, right? So I have that Dijkstra, yes. I mean, Dijkstra is himself is an algorithm. So having a definitive code skeleton for it does not do much of a justice. Here I'm talking about problems that do not specifically have an algorithm specified for them. Yet you can come up with finding. For example, if you go by the same Dijkstra logic, you can use all the cycle detection problems, and you can break that down in one. We could call write a code skeleton out for it, right? But that's not necessary since there already are uh, algorithms that do precisely that. So we don't need to go into that. But finding a format or finding a code skeleton for problems that already exist, that do not exist already, and like a pattern that you have identified, that helps a lot. It helps in BFS and DFS implementations a lot as well. So these are things that I can think from top of my head. I look into my notes to see what other notes that I have, but these are surely ones to go for. I think this is these problems have helped me. These code skeletons have helped me a lot. Um, and in my sessions, I also cover how you can come up with these code skeletons and how you can write these code skeletons. So that's also, I mean, it's a process. It's something that you do by learning. And and one thing that I can share is it helps if you are solving the same uh, algorithmic problems at a stretch or same data system problems at a stretch. It gives you an idea of how these things behave. Next question is from Maya. Kushba, I hope I answered your question. Maya, do you recommend writing pseudocode before actually beginning to code? Yes and no. So the answer to this depends on the kind of company and the kind of person who's your interview. Simple as that. There are folks who do not prefer writing pseudocode because in a 40-minute or 30 or 40 minutes interview, if you write the pseudocode and if you do not actually get to writing the coding part, it is a concern. Okay, there are many interviewers that make you run your code as well, and in that scenario, also you need to make sure that your code is working fine. So it's a good habit to know how to write a code before writing a pseudocode. Okay, I mean, if you can do it, if you can come to the actual code before writing the pseudocode, then it's a good practice. However, if your interviewer is okay with it, and if they want you to write the pseudocode first and then go to the code, you can go that route either. You have to basically ask this to your interview about what they are comfortable with. Some interviewers also have the ability to understand the code implementation directly from the code instead of the pseudocode. So in those cases, they would probably push for you writing the code. However, some interviewers, they like to understand what you're trying to achieve. So they make you write the pseudocode first and then go for the coding part. Pseudocodes also come in handy when the choice of language that you are using is different from the choice of language that the interviewer is using. So in that scenario, knowing how to write a pseudocode comes in really handy. I once interviewed at a company where the interviewer worked on JavaScript and I was coding in C++. And in that case, there is not much difference per se. Okay, there are not many different concepts or topics. But over there, it helped me to have knowledge of how to write a pseudocode so that I could get both of us on the same page. Because at the end of the day, my purpose is not to just go ahead and give my interview exam or write a code. My purpose is also to make sure that my interviewer understands what I'm trying to do or say. So, yep, I mean that's my answer. Does that make sense, Maya? Uh, let's get to referrals later. I mean, that's something that's a completely different conversation. You can probably connect with me on LinkedIn and shoot me your career role, the role ID that you want to go for, and your resume directly instead of just a plain hello. And if your resume looks like a good fit, and I see that the skills that are mentioned in the job ID are actually skills that you have in your uh, experience or in your career, then sure, I have no problem in referring someone. Any other question, Maya? I hope your question was answered. Okay, all right. So moving on. Uh, I have collaborated with Carrus over here to lay out an offer for just some limited time for folks who uh, want to go ahead and have personalized coaching sessions scheduled. So each coaching session is generally 1 hour long, and as per this particular package, I'll be providing one free coaching session for every three booked to help you in all the and provide any of the services that I've mentioned uh, over in my third or fourth slide. It's a package that is there in my Carrus profile, and it's available for a limited period of time. I'll not plug myself anymore. I'll just move to the next slide and get right down to things that we studied. And just to summarize what we have done so far, we in this session we learned about how we can create a study plan. What are the key topics we have to include? how to make notes, what are code skeletons, how to write, the 9 step interview approach, and of course, I have taught myself here again. So you can ask me anything on the Carrus.io community. You can just shoot a message and you can shoot a question and I'll answer that. So, yep.
Thank you, Harish. I think we just have one question. Somebody asked,
Yeah.
what are the
Yeah.
skills that is most required to crack
Hmm.
companies like Microsoft? Like, what are the interviewers looking for?
Hmm.
What are the specific skills they are looking for?
Right. Thanks for asking this question, Manoj. It's very important. This is a very important question, and I'll try to go past just the technical part of this and also cover the behavioral part of it. Okay, might get boring, but very important. As far as technical skills are required, it's essentially just any stuff that you would require. Yeah, I'll cover the tech skills first, and maybe you can zone out from the behavioral skills later. As far as the tech skills are required, writing efficient code, right? Uh, knowing, being very familiar with your data structure and algorithm, having an understanding of the requirement and being able to deliver on them, being a self-starter, okay, being able to do your research. Because let's say you're a back-end engineer, but tomorrow there's a need for a front-end component. Microsoft at Microsoft, the engineers are expected to be a self-starter. I joined with back-end hope, and I've in my career so far, I've done literally everything. I did front end, which I never thought I would. I did ingestion, I did DevOps. I have done all. I've done a bit of everything here and there. And one thing that I understand is Microsoft is a company, and I think all the FAANG companies, they have their they have the they provide the exposure for trying out everything. Okay, the learning curve is immense. Maybe the work load differs from time to time, but the learning experience in different fields is immense. And even if it's not related to your work, you'll find opportunities to learn from here and there. But in return, what Microsoft expects from you is that you are willing to learn as well. You are not a closed box who is there and who is just willing to do what they already know. You need to be a person who identifies themselves as a learner. As far as tech skills are involved, it really differs. I mean, if you're appearing for an SD1 role, just data section algorithms would do best. But if you're going for an obviously relevant experience that is mentioned in a job ID, it differs from team to team. For SD2 roles, you would need to have knowledge about your design concepts, your high level design, low level design, your knowledge about the different products and services available. Uh, in any Microsoft team, knowledge of Azure is a huge plus because there's always some or the other implementation that comes in using Azure. Even if you're on the on-prem teams, you would need to be familiar about the uh, platform of Azure and things that are being implemented in Azure and how are things implemented in Azure. Even if you're in some other team, you would need to know basic concepts like Azure networking or Azure Active Directory, okay, so to understand how authentication is done. And a little bit of Office comes in very handy as well. Okay, that's just side stuff. It just adds to your plus. But then try to get familiar with as many Microsoft tools as you can. Uh, Try to get certifications to show for your uh, try to show certifications for the stuff that you have learned. Microsoft has a huge line of certifications, exams. Try to appear for them. Try to gain as many certifications as you can, so that it's a living proof of you, that you know your knowledge and your work. So that's another thing. Behavioral wise, it's something that people consider boring. However, I joined Microsoft straight out of my college. Okay, and I understood the importance of I understood the importance of culture. I'm not kidding. For a person who jumps out of college, seeing the culture that I see at Microsoft, I didn't I don't take that for granted. I think it transforms you. Any company that you're going for, be mindful of the culture that the company promotes. Uh, be it the work-life balance, be it the way it treats employee, what is its mission, what is the company trying to achieve? Is it trying to make a better version of yourself? Do you have sense of growth over there? Um, just that at Microsoft, our vision is to empower every individual on this, every individual and organization on this planet to achieve more. And that's a very strong feeling to have, that at any point of time, my work is going out and it is actually helping people to do better, right? It's a very great uh, way to go. I hope that sort of summarizes the question. It was a long question. Thank you, Kushbu, and thanks, Santosh. Manoj, when it comes to programming language, what are some most important language to learn in depth? Uh, Anything that you're comfortable with, man. But if you're talking about usability, I think in the current market, uh, I can give you five languages that could be the best, and they're very interconnected. You can use either one of them. But Python, Java, C++, JavaScript, and lastly, but the I don't know, I think a revolutionary language if you haven't played Golang. The number of companies that have started using Golang is immense, and it's not that difficult to code, and it's a very user-friendly language as well. So Golang, if you're starting afresh and if you want to start with a new language, I would say go for Golang. If you are already coding and if you have some language that you use, practice that. No company will ask you to know a particular set of language until and unless it's a very hard and fast rule. And there are plenty of companies. If one company does not meet your language standards, maybe you can go for other company. At Microsoft, we primarily use C Sharp in most of the projects. Again, depends from team to team. There are so many teams that use Python and C++ as well. And we use a lot of React in front end. So some knowledge of JavaScript also comes in handy over there. But yeah, I mean, if you're applying for an interview, right? I think you will in the career page it will be very openly written that a similar language is fine because we understand that learning a language is not the difficult part. Knowing how to code is. Uh, Sondos. I hope I'm pronouncing your name right. I'm so sorry if I'm pronouncing it wrong. But fastest way to prepare for an interview in a few days as a fresh grad. Hmm. Um, I think it depends on where you are. Okay. When you say fresh grad, I don't really know where you stand. I could say that you could please call me Harsh. Please don't call me sir. Uh, the fastest if you're graduating fresh out of college, right? And if you have no idea about your data structure and algorithms, then I can't give you a few days time. But I'm just going on an assumption that you have practiced your stuff and you know your stuff, but you want to gain some confidence and you want to practice a lot of problems and you want to identify the get your proficiency up a notch and get in touch with your coding skills. I would say you don't need to study a lot. You need to practice, right? Pick up your topics, go to Lead Code or a coding website of your choice. You can go for Code Chef, HackerRank, HackerEarth, anything. In these places, try to find the topic that you're trying to brush up on, okay? And start solving the problems from easy to hard, okay? That gives you a sense of where you are and also helps building your intuitions better. That you see a family of problems and you try to identify it also helps in writing code skeletons for yourself. So that that is there. So I think that's it. And I'll say if let's say if you have design questions and everything, pick up the Grokking the Design interview book and just get started with it. Get going with it. That's more than enough. But for DS and Algo, I would say just practice if you're trying to prepare a few days before the interview. Also, as if you do not have an interview right now, be mindful that you might have an interview later. Okay. So have this separate set of questions that you keep for yourself that give you a good idea of how a problem can be solved. Probably while preparing any difficult problem that you got stuck on, right? Keep that to your this short knowledge repository, and every time you have to revise, just know that classify these into topics, and for a particular topic go for the problems that you once got stuck on, and if you're not getting stuck again, remove that from the list and just go on. That's how I do it. That's what helps me.